Very often when we're working with radicals, at some point we end up with radicals in the denominator. And it's just sort of a format rule in math that we just don't leave radicals in denominators. We wouldn't leave, for example, that or that as an answer because they both have radicals in the denominator. The process of getting radicals out of the denominator is called rationalizing. And one thing we should mention, since we're working with fractional exponents now, that if we have something like 3 over x to the 1/2, this is a fractional exponent, but because this is equivalent to root x, this would be the same as having a radical in the denominator and would also need to be rationalized. It would need to be changed in format so that there aren't any radicals in the denominator. On the left, we've got one with just numbers and a bit of review about how we would take care of this. We'd say, well, we could get rid of root 3 by multiplying by one of these magic ones. We could multiply by root 3, top and bottom. That would give us 2 root 3 on top. Root 3 times root 3 is 3 on the bottom. So this would be equivalent value to what we started with, but in the acceptable format where there aren't radicals in the denominator anymore. And it would be similar if we had, in this case, not root of a number, but root of a variable in the bottom that we could multiply by root x over root x. On the top, we'd have 5 root x. And on the bottom, root x times root x is x. And that would be the final version of this. Whether this was given to you as a question directly, or maybe the question was something else and you sort of ended up at that spot and you said, oh, okay, that's my answer. Oh, wait, there's a radical in the denominator, so I need to rationalize it because I can't leave that there. This does get a little bit more complicated. So I want to look at a couple more examples of things that can come up here. For now, continuing just with square roots though. This is an example where we have a square root in the denominator. And in this case, there's both a number and a variable inside. So what we would do is, and we're just looking at this part, that 2's fine, we can ignore it, that's fine there. What we want to multiply by is, in this case, root 3x, top and bottom. That's what would get rid of this radical. So our result would be on the top, 3x squared root 3x over, okay, on the bottom, so we would still have that 2. These two parts, root 3 times root 3 is just root 3. Pardon me. I completely misspoke all of that. Root 3x times root 3x is just 3x. Okay, that's what I meant to say. And so our final result would be 3x squared root 3x over 6x, except it's not actually our final result because this fraction can be simplified. The top and the bottom have a 3 in common. They also have an x in common. So we could reduce what we thought was going to be our final answer here. So the 3 and the 6 reduce to a 1, which I don't need to write, and a 2 on the bottom. X squared over x, so a single x cancels and we're just left with x on the top. And then that just is what it is. And so this would actually be our final answer. There's no radicals in the denominator, and just like any other fraction, it's fully reduced. Okay, let's look at another one here. Things now are going to get a little more complicated because now in this example, I have a cube root. So no longer just a square root. The problem here is that if we kind of do the same thing, well, that wouldn't actually take care of the problem. That would get us, the denominator would be that, which we still have a radical in there. So that's still a problem. So we've got to think a little bit harder about what to do here. We eventually want to end up with something that simplifies to not having a radical at all in the denominator. And one way we could think of this, again, that 2 is just going to come along for the ride, so I'm just going to put that on the bottom. What we'd like to end up with is cube root of x cubed, because that would just be x. Okay, so let's look inside here. What do we need to multiply inside the radical? What do we need to multiply x by to get x cubed? Well, inside the radical, we would need to multiply it by x squared. And so that's what we're going to multiply by, top and bottom. So on the top, we would get 5 cube root x squared. That would carry over here. Again, the idea here is that we need to end up with something that we can actually take the cube root of, so there aren't any radicals left in the denominator. And one way to think of that is we need to end up with the cube root of x cubed. Okay, if we start with the cube root of just x, our question was, what do we need to multiply by so that we end up with the cube root of x cubed? Well, if we have x inside the radical and we need x cubed inside the radical, then we need to multiply by x squared inside the radical. And that's what we do on the top and the bottom. There's another way of looking at this, either to understand it or just another way of actually doing it with fractional exponents. So I want to show you what that looks like. So I'm going to write this as x to the 1/3. I'm going to kind of do the same process here. And what we want to end up with in the denominator is just 2x, right? No radicals there. And so our question is, what do we need to multiply x to the 1/3 by to end up basically with x to the first power? Well, the answer is x to the 2/3. X to the 1/3 times x to the 2/3. We would add those exponents and get x to the 3/3, x to the first power. And so that's what we would do, top and bottom. And you can see it's exactly the same thing. This is x squared cube root. This is x squared cube root. These are exactly the same thing, just two different ways of visualizing or understanding why this, or this equivalent form, why that's what we need to multiply by, top and bottom. And so just to finish this one up, on the top, we'd have the same thing, 5x to the 2/3. And so you can see we end up in the same place. If we converted this back to radical form, it would be 5 cube root x squared over 2x. So either way of understanding it is fine. Either way of doing it is fine. Let's apply that thinking to one more here that's even a little more complex. Now it's a 5th root. So, all right, let's see what we need to do here. One way of thinking of this is that we need to end up with something that we can take the 5th root of. So we could take the 5th root of x to the 5th. So that's where we want to end up. What about the number part? What's a number that we can take a 5th root of? There's not many. 2 to the 5th is 32. So 32 is something that we could take the 5th root of. That's where we want to end up. So what do we need to multiply by inside the radical? Well, to go from 8 to 32, we need to multiply by 4. And to go from x squared to x to the 5th, we need to multiply by x cubed, all this inside the radical. And so that's what we would multiply by, numerator and denominator. So ultimately, we would get 3x 5th root of 4x cubed. And so our final answer, this would be the numerator. 3x 5th root. Make sure when you're writing these that they're like clearly inside here so that it doesn't get confused with being an exponent on that. Just a little note there. Over, and remember, we came up with this on purpose so that it would simplify. The 5th root of 32 is 2. The 5th root of x to the 5th is x. And then one last step that we have, again, we thought that would be the final answer. Turns out it's not, because there's an x that could cancel top and bottom. And so our final answer would be 3 times the fifth root of 4x cubed over 2. And I'll show you again how we would do this in the fractional exponent way, which you don't need to. This is the final answer. This is perfect, but just to show you how to do it using that other method. So if we have 3x over 2, now I'll write this as, let's see, is this going to be useful to write it this way? Let's see what happens if we write the number this way. It might be a little iffy here. So I'll do 8x squared to the 1/5. So that's going to be 3x over 2 times 8 to the 1/5 times x to the 2/5. Okay, I think what's most useful here is we can tell that to get what we want in the denominator, which is x to the first, we have x to the 2/5, we need to multiply by x to the 3/5, top and bottom. That's the same thing we did here, right? X third power, fifth root. Boy, as far as the number, what you'd really have to do for this to make sense is you'd kind of have to write it this way. So 8 is 2 cubed. So I'm going to rewrite this part as 2 to the 3/5, right? And then I'll keep this there. I'm sorry, that's a 2. And so now we can kind of tell, okay, to make this 2 to the first power, I need to multiply by 2 to the 2/5. That's what's going to add up to 1. And so I need to do the same thing on top. So that's a little more confusing with variables. It might be easier to think of, okay, what's the number that I can take the fifth root of? What do I need to multiply 8 by to get that? But I think with the variables, like x here, thinking of this as x to the 2/5, so we need another 3/5 to get x to the first, I think that's a fairly reasonable way of doing it. But we would ultimately, when we simplify the radicals, we'd get this same thing in the numerator. So when you've got square roots, the simplest version is just whatever your radical is, multiply top and bottom by that. You've got root x, so multiply by root x over root x. You've got root 3x in the denominator, multiply top and bottom by root 3x. Always see if there's anything that needs to be canceled at the end. Definitely the trickier ones are when you have cube roots, fourth roots, fifth roots, and you've got these two methods to choose from. You can think, for example, if we have a cube root, what would I be able to take the cube root of? And what do I need to multiply by to get that? You could also think in terms of fractional exponents and what would give you a first power in the bottom so that there's no radical involved. And then we saw an example of that was even more complex with a fifth root, but it was the same idea. We've got a fifth root. Okay, what can I take the fifth root of? I can take the fifth root of 32, and I can take the fifth root of x to the fifth. And if I'm starting from here, what do I need to multiply this by to get 32? And what do I need to multiply this by to get x to the fifth? So that's probably the best way to think about these higher degree, I guess, radicals, the cube roots and fourth roots and fifth roots in these situations.